The Uplift Weathering Hypothesis by Maureen Ramo explains how plate tectonics are responsible for changes in atmospheric CO2 concentrations. The uplift weathering hypothesis claims that the amount of fresh rock available for weathering is the driving force of climate. The main cause of uplift is two convergent continental plates. An example of this would be the Tibetan Plateau. Uplift causes mass wasting, steep slopes, mountain glaciers, and orographic precipitation, all of which increase rock fragmentation. Through excess fresh rock and precipitation, CO2 is removed from the atmosphere via weathering, and the climate cools. The sun emits short-wave radiation to the Earth's surface, which is absorbed and re-emitted into the atmosphere as long-wave radiation, also known as heat. With a high concentration of CO2 in the atmosphere, heat will be absorbed, leading to a warmer climate. When two continental plates converge, uplift occurs. As uplift is taking place, new fresh rock is exposed and left vulnerable to chemical weathering. As elevation increases, an air parcel begins to condense and eventually will precipitate onto the fresh rock. This process is called orographic precipitation. The process shown is called hydrolysis. It occurs when CO2 dissolved in rainwater hits freshly broken limestone. This pulls CO2 from the atmosphere, which cools the climate. With less CO2 in the atmosphere and with constant insulation, less heat is being absorbed by greenhouse gases, which leads to a cooler climate. The process of uplift weathering is a negative feedback loop. Uplift leads to an increase in fresh rock surface area at high elevations. This is weathered and subsequently removed CO2 from the atmosphere, leading to a cooler climate.